Right, welcome back to our next session. I'd like to introduce Libby Kinsey. She's recently joined Ocado Technology as head of data science, strategy, and operations. And she's going to talk to us about scaling data science. We've talked about building models that check the models. We've now had a presentation from Maria around collaboration and such. But how do you scale it? I mean, there's lots of talks about big data. What does that really mean at the end of the day? So I'm really looking forward to this session about being able to scale AI and ML in an operational environment. So Libby, over to you.
Thank you, Mike, for the introduction and the Tommy Flowers Network for the opportunity to contribute today. So yes, I'm Libby Kinsey. 6 months ago, I joined Ocado Technology. And as Mike said, that is in the role of head of data science, strategy and operations. If I were to summarize the job description, it would be putting it all together and running the AI factory. So I hope that my talk fits in nicely with today's conference topic. I'm going to tell you a little bit about Ocado Technology and then a very short story about my journey to the job that I'm doing now of scaling data science. So first, that little bit about Ocado Technology. For those of you that don't know, Ocado Technology is the division of Ocado Group that builds the technology platform known as the Ocado Smart Platform that powers our end-to-end retail solution. End-to-end means that our platform delivers everything from e-commerce, that's the web shop front-end functionality that you might be familiar with, to fulfillment, how we get products from suppliers to our retail partners' customers, and logistics and supply chain, how we manage stock replenishment and on-time delivery of products across the supply chain. And by offering an integrated end-to-end platform that's highly automated, we can enable the world's largest retailers to offer the best customer experiences and benefit from unmatched economic returns. As you can imagine, this is a huge technological challenge, and it means leveraging advanced technologies such as robotics, artificial intelligence, machine learning, and data science. And Ocado Technology is now some 3,000 people strong. And within data science, we've got teams embedded in every part of the Ocado Smart Platform. They're working on deploying diverse applications from things like demand forecasting, search, recommendations, routing, object detection, and robotic control. So that is, we know how to do data science at scale. The next big challenge is about reducing effort to value. So scaling data science is hard. About me, I've worked in technology for my whole career, but it's been a bit of a circuitous route, hence the squiggle on the slide, into data science and machine learning. I have liked to describe it as an atypical journey, but as it's only in recent years that data science degrees and apprenticeships have been available. So maybe this just shows my age. A lot of people have got an atypical route into this realm. So 10 of those years of my career were in venture capital, where I was investing in startups, commercializing innovation in the physical and computer sciences. That was an absolutely brilliant job. You get a really privileged preview of technological advances and their leap, or not, to real world application. And one of those areas was, of course, machine learning. By luck, really, more than intent, I found that I was invested in some startups using machine learning, and I started to see many more. I thought, this is going to be the next paradigm of computing. I want to be part of it, but I don't know how to evaluate the technology or the opportunity. And so ultimately, to try to answer those questions, I did a master's in machine learning at UCL in 2014. And, you know, upon graduation, I felt really pleased with myself. I really, really knew my machine learning onions. But that feeling only lasted for a short while. And what followed was a bit of a come down. And it turns out, and this has become an oft-quoted truism, but everyone has to learn for themselves, algorithmic innovation has very little to do with successful deployments in the wild. So how does one translate machine learning promise into really useful products and services and wildly successful companies? A few questions. The first problem I encountered was this one. When is data science or machine learning actually useful or adding value? And this was 2015. And despite having done a lot of data science and machine learning, I wasn't really aware of very much that was in production. Aside from, say, the recommender systems, search, spam filters was always used as the example. It wasn't obvious that the promise of machine learning had resulted in many deployments that were bringing business value. And at that time, Siobhan Zillis at Bloomberg Beta, Matt Turk at First Capital, they'd published the first of their machine intelligence startup landscapes. And I and a couple of friends thought, well, that's a bit North American focused. Maybe we can draw attention to the talent and expertise in Europe, which we did with this, the European machine intelligence landscape that's pictured on the slide. It's horribly out of date now, but maybe a few observations about putting it together and what's happened since. So it does focus on startups, but the picture was the same in industry. Outside of the sort of FANG data first companies, it was really, we were at that time valuing potential rather than reality, and had not yet bridged the gap into industry adoption. The other question is about where should one be doing machine learning or data-driven products and services at all. Objective functions, i.e. what we're trying to optimize, the mathematical objective, rarely are equivalent to what the real life objective is. They don't take account of real life constraints or completely satisfy business objectives. So the translation from academia to real world is hard. And it's always worth asking if data science is the right approach and how to demonstrate its value. I think I was listening to James Hamilton earlier, where he was talking about how the question of attribution is hard. Typically, data science is deployed as part of an overall solution in a non-stationary environment. So how do you know that it actually has added value? And thirdly, data science is very much not a SaaS business model. I.e., you don't actually have the economies of scale that were hoped for by many of the initial investors, at least. There's constant iteration, improvement in costs, tailoring to different circumstances and customers. And this brings me to the next challenge. So why wasn't data science or machine learning translating into impact faster? Why is the effort so much more than the perceived impact, or at the time, the perceived impact? And I think the answer to this is something that I called AI plumbing. AI plumbing was all the stuff you need to do to deploy a data-driven service that isn't the core algorithm. And I think Tuba presented a framework that I think came from a Google technical debt paper, which showed that machine learning is a tiny box surrounded by infrastructure and tooling challenges. And this was one of my attempts to map the tools and services that were available through the machine learning development pipeline on the x-axis, so i.e. from the potential, the idea, through to utility, and against physical to abstract on the y-axis. So we've got the hardware layer at the bottom and some of the more process-oriented stuff at the top. And this is still an immature and very fast-moving space. So first of all, you need all of this to deploy. And at the same time, everyone was working out for themselves and writing their own scripts and tools to automate parts of the pipeline and switching frameworks, languages, infrastructure frequently, which was okay-ish because they were small teams and anyway, didn't really have anything in production yet. But even now, there is some agreement about what constitutes ML ops and what good ML ops looks like. There's still a lot of work to do. You can see that there are many other processes and functions which need to work together to build a low friction, high productivity data science machine, and hence the importance of technology change management and culture in successful data-driven organizations. But even if you get all of this right, there's another question. So if data science can create value, why is there still hesitancy to adopt it in some areas? And well, one answer, in addition to lack of data and the cultural change and change management needed in traditional industries, is the growing awareness of unintended consequences of large-scale deployments of data-driven products and services. I probably am rehearsing things that you've heard several times already today, but questions of bias, of privacy, safety, security, accountability, human dignity, and flourishing. something that's non-stationary, non-deterministic, difficult to explain, understandably causes boards and decision makers concern with respect to their legal and moral duties. I wanted to know how we can responsibly deploy data-driven products and services, and spent time in my previous role at Digital Catapult building processes and tooling in support of this objective. And the picture here is from a paper that I co-authored with Jess Morley at the University of Oxford and my colleague Anat El Halal. Again, it's mapping tools, those tools that were available at the time, against the machine learning lifecycle, and a set of ethical principles which are deemed to represent a kind of consensus. There's loads more I could say about that, but I will limit myself to two things. Where tools exist, this is what we found. It's not obvious when and how to use them, or they are difficult to use and access. And the more fundamental thing, which was sad for me as a technologist, tools don't matter unless the right culture and processes are in place. So, in summary, data science has developed a lot over the last few years, and the challenges have changed. Doing data science used to be hard. Now data science and machine learning is easy. Scaling machine learning, how to make sure that your algorithms can serve large audiences with low latencies, that used to be hard too. But Ocado Technology, and I can take no credit for this because I'm new, has solved that problem multiple times over. What we need to do now is build a data science factory, make it as easy as shopping online. And that needs us to know why we're doing what we're doing and to do it well. So to go back to my previous slides, it's being able to show impact and value of data science, i.e. the right metrics, experiments, the storytelling around it, to be able to reduce effort to value with great plumbing and processes, and to be able to do it within a framework that results in products and services that are sustainable and trustworthy. I think this is maybe one framework for looking at how to scale. Maybe another one that I've heard in many of the presentations already today is actually it's about people, processes, and platforms. So I'm just going to end with one slide that says, we're recruiting. I hope that I have inspired some of you listening today, and I will hand back to Mike.
Great, thank you very much, Libby. One thing, a fascinating insight. I love you're the second person that's mentioned Elon Musk in 2 days now. We're going to start a bingo card about how many times he gets mentioned over future sessions. But I love the quote about design's overrated, manufacturing's underrated. I do lots of work with manufacturing companies and couldn't actually agree with that comment anymore. So I'll bring this particular session to a close. Thank you once again, Libby, and I'll see you over on the next session in just a moment where we're going to hear from Dr. James Grant from Lancaster University. Thank you very much.